With the first computer I got from my father, and the computer just didn't do anything without you first programming it, just like learning a language. You develop some kind of fascination for it and you start creating things. Just like some people write stories or write poems or it became some sort of a hobby to do. It's very powerful if you, just with a few lines of script you can generate a lot of information, well, let's call it, you can design a lot of content. Like scripting is the same as drawing and sketching. I'm not a very good drawer or sketcher, but like if I see people drawing buildings by hand, they're just doing things and then throwing it away and doing another one and altering it a bit and taking other colors, putting it over, and that's the process. That's the same. You do the same with scripting. You write a script and it generates something. You say, oh, that's not exactly what I want, and you alter it. And so the whole creative process for me is the same. It's a tool, like a pencil is a tool, and I don't think that one of the tools is the best tool or something. It's always the person using the tool who actually determines if it's good or not. It differs per project. Sometimes you use pen and paper, sometimes you use Excel, sometimes you use... We at the architecture firm work a lot with, obviously with SketchUp also in the very first phase. But a lot of it is still done by hand, drawing, and then put into a model, manipulate the model, and then later on it's drawn in AutoCAD or most of it now in Revit. Just to be able to, if you manipulate the design, to have immediate feedback of the numbers that you're manipulating. The only difference is the resolution of the buildings. Like CAS went on with more fluent lines, and at CPZ we went on with more orthogonal buildings. You don't want to have a cut between your design and the building process. You want to have one fluid process. So you're designing, and at a certain point you're building the building. And I think that's still very similar to the way that we used to work with CAS. And the first buildings I did here with CPZ were like box-like buildings, very simple volumes. But there we focused on also on like the file to factory kind of way of producing buildings. Right? So it's I went from the more experimental way of using computer in design to a more practical way of using the computer in the building process also. And if you start thinking about just building efficiently, and you start thinking about more prefabrication to have more labor, not on the site but in the factories, and then at a certain point you are making a building that is assembled on site only. That's not built on site. It's only assembled in bigger blocks. In the end, that should be the way to build buildings like that, just to have the minimum material printed for that custom building. But at the same time, you should have buildings that can also have that can adapt to developments in society. So you make a building for the first client, but then after 5 or 10 or maybe after 50 years, if you make it very specific, like if you have an algorithm that generates a building exactly for that function, then you might have a problem after 5 to 10 years when you want to have a different function in the building. You have to have a long-term view. You have to look at what can we do with the building after 10, 20, 30 years. And that's very different from the way that buildings are developed currently. You only look at the first 10 years, and well, what comes after the 10 years, I don't matter. Then I've earned my money and it's okay. I don't mind what happens next to it. So we're very much into just scaling up this way of thinking about building.